Hello and welcome to part 2 of the multiplayer framework plugin. We're going to kick straight in and create our project. I'm going to be creating it in Unreal Engine 5.3.1. You could probably do this in any version of Unreal Engine 5, but I can't guarantee you won't have issues. If you do have 5.3.0, I'd probably stay with 0.0, as I've got a fix for the 0.1 issue, but there is one issue with 5.3.1 with some of the plugins we'll be using. So I'm going to launch a 5.3.1 on the new project screen. I'm just going to create a blank project, C++. I'm going to call this, this is just a project to put our plugin in, essentially, so it doesn't really matter what you call it, but I'm going to call it multiplayer plugin. Right, once we've got your code editor and the engine up, we'll start in the engine. We'll go straight away and create the plugin. Go to your plugins, click add, pop up with some plugin templates. We're just going to be creating a blank template. You can plug in an author name. Doesn't really matter. It's just sort of metadata for it. And we'll just put the name in here, and I'm going to call it multiplayer menu. Click create. Alright, once that's created, while we're in here, we're just going to add the CommonUI, because that's addable through here. CommonUI plugin, just add that. That prompt is just saying it's a beta plugin. So that's all we need in here for now. We can close this because we'll need to rebuild anyway. So what we're going to need is we're going to need the latest version of Lyra. So whatever version of Unreal 5 you're using, you'll need to get a version of Lyra at that same version. So if you go to the marketplace and just search for Lyra and just create a project with that latest version. I've already got one, so I'm not going to do it, and that'll pull down all the Lyra files. And the reason why we're doing this is we just want to get a couple of plugins out of Lyra. They're not available through the plugins in the editor. So once you've got that done, you should be able to browse to that installation of Lyra. And that should look something like this, and just go to plugins. And then we need to grab CommonGame, CommonUser, and ModularGameplayActors, and just Control-C to copy those. And then go to wherever you installed your the multiplayer plugin project. So this is where I installed mine, and I'm going to go to the plugins directory. You should have a plugins directory with your plugin there, and I'm going to drop those in. So the CommonGame, CommonUser, and ModularGameplayActors. So now into our whatever IDE you're using, whether it's Writer or Studio, let's go to Game, Plugins, and we need to edit the build for the plugin. So not for your main game. Make sure you're in your multiplayer menu plugin. So this is where we have to say this plugin requires these other plugins, so they're dependent. If this plugin is dependent on these other plugins. We don't need core, slate. I'm going to add some others, not just the common ones. I'm going to add the add-ons we're going to need later on for doing the multiplayer menu. So networking, netcore, we'll need UMG, and we'll need online subsystem. And then actually that can be in the public, sorry. So that can go up here under core. Just watch those commas there. Down the bottom here, we want to add with a comma our CommonUI, CommonUser, CommonGame, and ModularGameplayActors. Now this highlight yellow is because we haven't rebuilt the project, which we'll do in a second. But we need to go into the U plugin of the mod now, of the plugin, sorry. And this is where it defines the plugins that it's going to load. We're going to add an additional dependencies list here, just like this. And in here, we're going to list those plugins that we just put in, like so. Underneath this modules section here, we're going to add a plugins section. And this is going to include the CommonUI, CommonGame, CommonUser, Modular Gameplay plugins. I'm not sure if we need online subsystem there. That's okay. We're using it anyway, so it should be fine. If you didn't change any of your data up the top, like the author or whatever, you can change that all up here if you're looking for that. So now we need to rebuild our project. So I'm going to close out of this. I'm going to go to the root directory, highlight the SLN, intermediate, and binaries, delete those, generate Visual Studio project files. Once that's done, reload. And now we can start creating our C++ classes. So back into plugins, multiplier menu, source. And this is where we're going to start here. So just close these. We shouldn't need to go back in there unless we've made a mistake. So the first thing we'll create is our game instance because we need to use the CommonGame instance. So we call it just S game instance. Again, I'm just prefixing with S. So I have unique naming. If you can use whatever prefix you want to use there, or whatever, however many letters. And we want to inherit from the CommonGame instance. And then I'm going to put it in. I'm going to make a framework folder and managers folder, and go in there like so. And then the CPP will be in here. I'm just going to put a constructor in here for now. So just the object initializer, include the super. That'll do for that for now. And then we'll create a game mode. Just off the game mode base, and that'll be in the managers directory. There's going to be quite a bit in here, so we'll just do the constructor for now, same as before. Well, let's start filling this out. We're going to override a few classes here. So the first one we want to override is our init game state. So in here, oops, in here we should have a valid game state by now. So I'm just going to confirm that it is our game state that we are going to use. Well, let's create that game state now. So haven't got an error there. So we'll go to managers, new class, S game state. I think it's in here, isn't it? Game state base. Let's just do the constructor. Same as before. Super object initializer. So back in our game mode, we should be able to include this now. We're going to use this to check that our game is loaded. So we're going to just go back here. We're going to have a protected function here. It's going to be called from a delegate, so we need the ufunction header, and this will be when the game's ready. So we'll make just a boolean variable for that the game is ready. We'll initialize it to false, put that in the header as well. So like so. In here we want to bind to a delegate on the game state. So the game state is going to be the one that tells us that yes, we're ready. And then this will be used to initialize the players with the game data that's loading. So we'll go back to our game state, and we're just going to add a delegate up the top here. So it's a multicast delegate on game state ready, and then we'll just add the variable down here. Make sure it's public so we can access it from the game mode. And then in the game mode, we'll bind to that. So in the init game state, this is where we know our game state's valid, so we should be able to grab a reference, bind to that delegate, sorry. So that on state, we're adding a dynamic delegate, and we're going to call our onGameReady function. And then the game mode knows the game is ready, and then we'll initialize some players. So let's create a function for that. There. initialize players. And then in here, we're going to need a list of players that have already connected. So it might just be, if we're the host, it'll just be us, but it could be multiple players, could be for a server trouble, could be everyone in the server. So, and how we're going to do that is we're going to override generic player initialization to start the building that list. So if we go back here, we're going to override generic player initialization, which occurs whenever a player connects. What we probably want to do is cast that to our player controller type. So let's create our player controller class. So we'll go to framework and we'll call it sPlayerController. And then we'll come down player controller and then we'll put that in the player folder. So let's do the constructor. Same again, just with the object initializer. And then in the protected section, we are going to use the onPossessed. So when we restart our player, we'll use the onPossessed to check if we want to display the menu or not. And then we'll have a function to show the menu. So in the onPossessed, we want to just check if it's the local controller. And then we'll check if we've got the world. It's all loaded and good. And then we're just going to get a reference to our game state because we want to check if we want to show the menu and get the menu class from the game data. So we'll do that through the game state, which will have the current game data, which is the game state. So we cast them to our game state. And then we have a reference to our game state. The game state we will want to get a reference to our game data, or at least in the game state we'll have a reference to the game data that's replicated, so then the clients have got access to the current game data. From the game data we want to check whether we're showing the menu or not, or if it's just a game we're going straight into. So we're going to need to create the game data and store it on the game state and do all this sort of stuff. So I think we're going to have to leave that there and then go back to our game mode and set up our game data. Well, let's create the game data to begin with. So in the public, I'll do it under framework, and we're going to create. It's just going to be called best game data. I'm going to put this into a data folder, and it's going to be a primary data asset. Our game data, we're going to want to define the data type. So this is sort of the templatey stuff I do for all data assets. So you got the data type and then you're overriding the get primary asset ID. So it uses that data type. And this data type is what we'll define in the asset manager so we can look it up as the correct type. Now there's a whole bunch of stuff we can store in here, and this will be what the game mode is. So you can define all the settings and everything for the game mode. So I'm just going to go through these one at a time. So we're going to just store a map. So that'll be our level that we want to load for this game mode. There'll be arguments that we might want to pass. So this can be custom settings and whatever else. We'll have our max players. So how many players the game mode's going to have. This will be the name of the map, or like you can use it as some other title, like could be the game mode title, like if it's deathmatch or team deathmatch or whatever like that. I'm just going to call it game map as for a name, and then the other one will be the game name. So you might have, like Just 2 or, and deathmatch or something, like they're the two sort of game titles, and then you've got a game description, so that will be more information about the game type perhaps. And then we'll have like a icon or a texture that'll represent that game, and maybe the level or whatever you want to display there. And this is a soft object pointer, so we can load it only when we need it. And then the one that we were just looking for now is whether we want to show the menu or not. And I'll show you the way that I set this up. Basically what we're going to do is we're going to have a default game data. So when you load the initial game, it'll grab the default data, which will say, hey, show the menu, because you're just loading the game. And then other game modes will have this disabled. So it'll make sense later. And then this one is whether you want it to show up in the list or not. So you might have some test ones, or you might like the default one, for example. We don't want to show that up as a game mode that people can choose to host a game on. And then this will be the class of the menu that you want to display, and this will be the class of the widget that each one of these game modes represents. So it's just a reference to a widget, really. I'm just doing the 4 declarations of that activatable widget and the common user widget. So that's them up there. And that's, you can extend this and add whatever you need, but this is all need for doing a multiplier menu for now. That's our data asset done. So now we're going to go to our game mode, and we're going to start setting up how we retrieve that. Like I said, retrieve the default one, and then also later when we host a game, how we pass around what game mode we chose in the menu. So whoever hosts is going to choose, a game type to play, and each game type will be one of these data assets. So in this protected section here, we're going to have a few functions that handle all the game data type stuff. So we're going to assign a game data. Once it's assigned, we're going to handle what happens when it is assigned, and then and that'll include loading it. And then when it's loaded, we'll do something else. And then this is just a check to say, have we loaded a game data, so we can do things if the game data is already loaded, such as when clients connect and things like that. So we need a property for that current game data asset. So this will be whatever is loaded on the server at this time. Put that down the bottom here, and then this function here is just a getter for the game data. So if anyone's trying to grab the game data from the server, they'll be able to do that. So I'm just going to find these. Oh, we've got to add forward declaration for the game data there. That's there. We could put the class in front here, whatever. And then we can build these. So for handling the game data, we're going to want to use option strings. So if you've never seen the option strings, it's when we looked at the game data, you're seeing this extra arguments here. And this is pretty much what option strings are. It's just a string that represents a piece of data. So what we can do is we can pass data into the hosted game to say, what game data are we using, and we can use that string to then retrieve the data class when the game loads. And then if we don't have a valid option string there, then we can just find and load a default one, which is what we'll do when we're first loading the game. So probably the last thing we want to do is just have a breakout for when we have assigned the game data. If the current game data is valid, then we want to go to the on-game data assignment function that we created, which is just below. And then if it's not, we want to tell the game dev, hey, you stuffed up, something's not right, and we'll just put error login. So we failed to find the game data. So now there's 2 ways we're going to assign the game data. We're either going to find it in an option string, or we're going to fall back to the default. So we only want to fall back to the default if the option string has failed. So if the current game data is not valid, then we're going to go into that. And the way we're going to assign this to the current game data is we need to find the default data asset, and we're going to do that directly by name. So you sort of create the asset ID, but just define its type and name. So if you recall, the type will be whatever we put it in as game asset inside the asset manager, but it's going to be game data. That's what I'll be calling it in there. The default name, we'll have to have some naming convention when we actually create the data assets in the editor. So for now, I'm just going to put this, and this is probably what it will be called. I usually start all the data assets with DA for data asset. It's going to be game data, right? So we want it to have a type, and then this will be the default one, and that's what we'll call it. And we just have to make sure that that's what we actually name the data asset. Whatever data asset we want to be the default data asset, that's what we have to name it. Now this can get quite confusing, right? So you're going to be using this a couple of places potentially. So this is where we want to set up defines for our string variables like this. I just call them static strings, and in the past I've put it in the H file, or I've created a custom H file for it and put it in there, and that's what I'm going to do this time. So in our data folder, I'm just going to create a file, and I'm going to call it static game data.h. So sometimes you only need the .h. For this case, I'm going to need a CPP later. So I'm going to create both now. So that's the H file. And then in the private data folder, I'm going to create the CPP manually. So it was a static data. And then I'll need to reference that. So a quick way of doing that is just to come into another file that's in the same directory, copy the include, and I'll change this to the static game data. It's got a reference to its H file now. So we don't need the CPP for now, we'll need it later. But this is where we want to put our defines in here. So at the top, I'm going to put the pragma once. So that means it only loads once. If it's already loaded, it'll skip. And then here we want to create our defines. So what I want to create defines for are these two strings. So I'm going to call them asset manager data types here. I'm just making up a name here. So this everything you see in capital here is just a made up name. You can use whatever you want. So I'm using a S prefix so I don't clash with anything else as usual. And then I'm calling it a data asset type. And this is the game data. And this is the default game data. So now now that I've defined these as strings or F names, I could probably just do that as text actually. I just want a string by the looks. So now we can replace this with our define, and we just need to include that static game data at the top. So that's there. And then if we need to reuse this string somewhere else, we can just use the define, and then we have a single source place to change it. So if we ever needed to change the name for whatever reason, and we want to change it everywhere that it's used, then this will give us that single source place to do that. So for example, if we decide to change the default data asset's name, then we could just go into that static game data and change it, and it will change everywhere because they'll just be using this define. Right, so now again, if the current game data is not valid, we want to check if we have the option string. So we can use that using gameplay statics as a has option function, and this option string variable here is part of the game mode. So it's in the game mode base, the class we inherited off, I believe. We need to have a setting for whatever that is, and it's already predefined option string here for game mode. That's what it passes as part of the default multiplayer setup. So what we're going to do is just add another static string reference for that, because we may have more multiplayer settings later too. So I'm going to add a multiplayer setting here called game mode, and this is how you reference the game mode anyway. So like either way you do it, I'm not making this up. This is like a prefixed thing in the multiplayer part of Unreal that has the actual game mode, and we're going to use that to store the name of the data asset. If there is an option string, we want to use it to create a string so we can create a data asset. So there's another gameplay statics option called pass string. So we're going to use that to make a string from the name of the game mode, which in fact will be the name of our data asset. So then we can set our current data asset to a new primary data asset, and we're going to do the same as what we did down here. So it won't be the default one this time. Will actually be, so the type will be a game data, an S game data, and then the name will be that option string. So we're saying whatever string name is used in here, that's the name of our data asset. So once we have that data asset from either way, we then need to go to the on assignment, and this is where we need to start just loading that data asset. So we're going to need to reference asset manager for that, including the asset manager at the top. Just going to check that we actually did and have a valid data asset. And then I've used this code a few times, so we're just going to define a bundle here. I'm not actually using a bundle at the moment, but what we might do is we might just set up a bundle in that statics game data. So if we do want to define something to preload later, like we can. So the bundle will be just, I'm just going to call it game for now, but we can use whatever that is later. So maybe there'll be some textures or something like that something for the UI that we want to have preloaded. We can do that using that tag, but you don't really need to worry about that too much now. So that's just adding that tag to the bundles. And the way that works, by the way, is in the actual game data. In the meta tags here, you can define bundles, and it'll actually search for those bundles. So for example, where's that texture? So if we had this texture as, if we had that tagged as the game bundle, and then it would preload that texture while it preloads the primary ID as well. So now we've got the bundle, we can assign a delegate as to what we want to do once the data is loaded, and we're going to call that onGameDataLoaded function that we created earlier. And then we're going to actually call the asset manager to load the asset, pass in our bundle and the delegate that it calls when it's finished loading this asset. And then when the data is loaded, we just want to check that we have a valid reference to our game state in case it happens ridiculously early or something like that. Like, it's unlikely, but we're just going to be using the game state, so we just want to check it's valid. We're going to check that our game data is still valid. We're going to cast to our game state. So now we need to actually cast our data to the actual class. So that'll be the class of the game data. So we're going from the primary asset ID to the actual class of the game data here, and that's what this getGameData function will do. And then if that's all valid, everything's valid, then we're going to tell the game state to set the game data, which we haven't set up yet. But we'll just finish this off first. So in here, we just want to, again, check that we've got a valid primary asset ID for game data. We're going to get a reference to the asset manager, and then we're just going to cast the object to the data type that it is, and we'll return. And then if any of those are having troubles, then we'll just return nothing. So let's now go to our game state, and set up this set data. So in here, we need that set data, and we're passing the actual game data that we cast to. And in here, just want to check before we try and do anything that that is actually valid. And if it is, we want to assign it to a variable. So create a variable for that and put this in protected and property. That's our game data. And now we want this game data to be replicated. So it goes to all the clients. We're actually going to use onReplicated for that. So we're going to go replicated using. OnRep game data. Now we have the OnRep game data. We needed the function for that. It has to be a U function, so it can link to the U property there. And let's wait OnRep like so, and we can build that. And then in there is where we want to fire off our on game state ready. That's where we're actually going to broadcast that delegate that we set up earlier. Once we set the game data, there's one other thing we want to do is we want to actually check if, oh sorry, we need to assign that. We haven't assigned the game data, have we? So if it's all valid, we're going to assign it to not new. So that's our game data set. However, because we have added this replicated, we now need to add the get lifetime replicated props. So if we go back to the CPP, usually put it at the top, you're going to need the get replicated props like so. And this is an Unreal class, and we don't need to implement it in the H file. It's got macros that handle that. As soon as you use or define that replicated header or property tag, then you can, it'll allow you to define the, it's like an override, I guess. Not an override, like a child class to the get lifetime replicated props, so you can tell it, hey, I want to replicate these properties. And we want to do REPL. Why isn't that coming up? This. So it's included the Unreal Network include up the top there. We just want to do it in this class the easiest way. If we need to copy paste it somewhere, it's always this class, so it works out. And it's the game data we want to replicate. So that should be our data handling. And then now we can go back to where we're up to with this player initialization. So we're going to go back to our player controller, and we'll here at the game state. And we wanted to check, we want the game state to be able to tell us whether we're showing the menu or not. So we're going to need a function on the game state to say, hey, are we showing the menu? So now that we have the game data here, this has whether we should show the menu or not. So if we just create a function, should show menu, this will just be reading, so it can be const. And now we just need to check if the if the game data is not valid, then we want to just return false. But so we'll just check that the game data is not null. And if it's not, then we just want to return whether to show the menu or not. So return show menu. So it could be true or false. Oh, I didn't do the return bool. Sorry. Yeah, and then if the game data is valid or whatever, we just want to turn false. I don't show it. Could put a error message there, but this might fire at different times, so it doesn't really matter. Yeah, so now in our player controller, we can call that function. So if we should show the menu, then we're going to call our show menu function here. And now we need a menu class to show. So that's also what we're going to get from the game data game state, and we'll get menu class. And this is a function we'll have to implement as well. So we're going to need a class that returns the same type here. Add the include for the common activatable widget. I mean the include the for declaration, and then in here we're sort of doing the same thing as here. I'm just going to copy this, but instead of returning the boolean, we're going to return the main menu class, and this will be, instead of returning false, be null. So we could potentially be passing a null pointer to this, so we need to check if it's null. So we might just make that is equal to null pointer, then we just want to return. Just ignore that. And now we need to do the actual loading of a widget. So this is how we're going to activate our widget and apply it to the primary game layout and all that. So we're just going to need a world reference like you usually do with widgets. And we're going to need a reference to our primary game layout. So it can just be the default primary game layout. That's fine. Because those stacks are registered, it's going to know the UI stacks are registered. It knows what it's talking to. So now we've got the root layout, we need to push the widget to the layer stack that we want to add. So ours will just be a menu, so it's going to be the menu stack. And it uses gameplay tags for that. So if we have a look at the function, so if we go root layout, it's push widget to layer stack async. And then you can see here it wants a gameplay tag and it wants a common activatable widget. Now it's got a boolean that for suspending, because it's async, it can suspend input until it loads. That's fine. So that's the main things that we're going to need. We'll handle the rest of it. The first thing we're going to need is a gameplay tag, and that's what I want to use this static game data for, and this is how you access gameplay tags in C++. So we're going to go to the static game data here, and we're going to add a namespace for our tags. So this will allow us to reference them. I'm just going to call it UI layer tags or gameplay tags, whatever you want to call it. It's just a name for referencing, you'll see. And then we'll need to include the native gameplay tags, so we can reference the macros it has to declare gameplay tags. And if you have a look, it's just like a define that we've got above, but it's ones that are in the gameplay tag. So you've got this gameplay tag, declare gameplay tag external, which basically means that you want to access the tag externally. And now I'm just going to define a name for it. This is what we'll use to reference the tag. So I'm going to call it UI layer. We'll do all 4 layers, so game. And now I'm going to duplicate this 4 times. And this will be game menu. And this will be the one that we're actually after, is menu, and then the bottom one is modal. And then we need to define the same in our CPP. In here, this is where we use another define, which is how we actually define the gameplay tag. So it's called define gameplay tag comment, as a comment at the end, I guess. So this is the name of the tag that we just made up, or what's called the reference to the tag, same as before. And then we've got the actual tag itself. So it's going to be UI layer game. And then the last entry is the comment, as it says in the define. I was just going to put in a basic. So that defines a gameplay tag, and we're going to do that for all of them again. Just using Control D to duplicate there. So this one was game menu. This one was menu. And modal. Layer.game.menu. And modal. So that defines our gameplay tags. Now if we go back to our player controller, so now we can use that namespace that we created, the UI layer. That's going to need to be included, and then we can reference those tags, so we can access our menu tag like so. So that's the tag done, and then the next one is true. We do want to suspend input till the widget is up, and then the menu class is what we passed in here. It's our activatable widget. Now the next part, it expects a delegate, so it's a little weird, but with the delegate we're just going to pass this function or this class, and it will want a layer state and a pointer to the widget, it looks like. So this will be, and then here we're just going to have a switch. Is that erroring out? I've missed a comma or something. What am I missing? Oh, oh yeah, so the reason why I'm getting this error is because I forgot to pass the cast type. So we just need a type in here, which is the common activatable widget. And that is what pushes the widget to the stack and loads it for you. So now that the player controller is good, we need to go back to our game mode where we start off originally and handle these initial players. So we needed a player list, and we just wanted to create a player controller class for this, but we sort of went on a tangent and did the whole rest of everything else. So now we can cast this controller here to our player controller, add the include for our player controller, and then we just want an array of the players in the session. So I'm just going to call it session players, put it down here under our game data, add the forward declaration for our player controller class. So we've just got an array of player controllers on the game mode, and then we just want to add this new player to that list and make it an add unique so that we don't get duplicates. And now that we've got that list on our initialized players, so this is players that are already connected, we can loop over those players. We'll make sure that they're valid players, like they exist in the world and they haven't disconnected or anything like that. And then we only want to do this if the game data is already loaded. So if we get to this initialized players before the game data is loaded, we just want to do nothing. And otherwise, we're going to check if the player can restart, and if they can, we're going to restart the player. Now, what we want to do is block the player from basically starting if the game data isn't loaded. So in the game mode, there's actually a class called handle starting new player. So in here, we just want to override this function. So in here, we only want to call this if the game data has loaded. So we just want to check for the game data. So I might just create a function for that. I'd already have. So we just want to use our check for is game data loaded and only call this super if it has. So that'll stop the player from starting up before the game data is loaded at that very start. Just confirm We have implemented that, haven't we? Yeah, that's fine. And then the other one we want to do is we've got our game ready here and the on ready notification. If somehow the initialized player gets to here and the game isn't ready, we want to block them at this player can restart. So we might have the game data, but maybe the game state isn't finished doing what it's doing, and we just want to stop the restart here. Before we forget, actually, let's just call this initialize players on the, make sure we call this when the game is ready. But just in case there's an edge case where we get to here, the game data is there, but the game isn't ready, we can then block them by overriding this function here. Again, that's another function that we can override in the game state base. And we just want to surround this with that B game is ready. And if it's not, turn false so they can't restart. Now, because we're skipping these things, we want to have a case that handles when the player fails to restart. So that is another function that we want to override. There is a failed to restart player function. And what we're going to do is we're going to need the super for this one. So we just, if the game is ready, but we failed for some other reason, then we're going to cast to our player controller. So this is just to check it's an actual player, because you could, AI uses this stuff as well. And we'll look at including AI later if we need to, but for now, we just want to recall and the player restart. And if it can't, we're going to do a log restart. We'll just put a log in here just to show that something's going on. It's not necessarily an error, because what this is going to do is create a loop that the player will sit there and try and restart until the game data is good to go, or the game's ready, I should say. So what we need to do is actually tell the player or the controller for this player to wait a frame and try again the next frame. So we're just going to create a function for that, because we'll also use this function to kick off the whole loading process as well. So just going to request player to restart next frame, and we're passing a controller and just a bool if we want to force it. And then if we are forcing it, we just want to reset the controller, and that just does a bunch of internal stuff, resets where it starts and all that. But what we want to do is we want to check that it is a player, and then we want to just use the world timer to kick off another restart of the player next frame. Nothing too crazy there, really. So now we need to call this function up here. So we don't need to force it, so we're just going to pass false, but we'll pass that new player in to restart next frame. If the game ready state is false, then we just want to go directly to restart next frame. So that creates that loop for the player to sit in until the game's ready, basically. Now, one thing we haven't done is in our game mode, we haven't kicked off the loading of the data, and that's because I was waiting to define this function here. So we can put that in our game state, our init game state function here. So once we've defined the delegate, we can tell the time manager on the next tick, just start loading the data. The next tick just gives it some time to replicate anything or do whatever it's doing. It probably would be safe to call directly, but this just gives us that little buffer. And then in here also, we probably want to reset our session players. So empty that, so we don't have any hangovers from previous sessions or something crazy. I believe that is everything. So we should be good to build our project now. I'm going to switch this to debug and launch debug mode. So this allows me to use breakpoints, and it gives me more information in those breakpoints. So we've got quite a fair bit to do once we load up the editor. First thing I'm going to do is just save this level. So we've got a level to use in our game data. And I'm just going to create in the content folder, maps folder, call it test map. And then in the, I've just brought in a texture to use later for the game data. You can use whatever texture. In the content folder, I'm going to create a new folder again. It's going to be called framework. And the first thing I'm going to do is create our data. So this will be the first one will be our default one that we talked about. So I'm going to go to miscellaneous data asset. going to find our SGame data. This had to be that exact name that we use, so it was DA underscore game data default. If you don't get this right to what you put in the C++, it won't find this. So we'll just save that, and then we can go, well, before I do that, let's go into our edit preferences and set this to main, because that's super annoying when it opens in Windows everywhere. In here, we can't fill in the data type yet. Actually, let's do that setup, I think, first. We'll come back and fill this out. So we'll just leave that open, but we'll come in here and we'll just create the other things that we need to assign in project settings. So go framework, and we'll go managers. The only blueprint class we need is the game mode. So we'll go, I mean, we could assign the classes in C++, I guess, but we'll just do it here. And then we just want to find our game mode. And then in here, we want to assign our S-player controller and our player state, game state, S-game state, sorry. And in here, I'm going to put save on compile always. Saves me having to do compile and save. So now in project settings, we don't have project settings up here. You just go edit project settings. And then we need to change a few things for CommonUI. So the first one is viewport. So the game viewport client, we want to change to the CommonGame viewport client. And the other one is local player. We want to change it from local player to common local player. And then we want to go to our asset manager, and underneath the primary asset types to scan here, we need an entry for our game data. So I'm just going to set this to always cook. It doesn't really matter, but I'll no doubt forget one day and it won't cook and I'll be freaking out. If you recall, in the C++, we set that string to game data, and this is where it comes from. This is where it's grabbing the name. So it's going to call this game data, and it's the SGame data is our class. There's no blueprint class, and then we just need to point it to the directory which we have created already, which is framework data. So that's telling it where to scan for game data assets. So you can't just throw them wherever. It's only going to be in this folder. You can get it to search the whole project if you want, but much better to do it this way. And then the last thing we need to do is set our maps and modes. We set our B game mode. Just check that that's set to our classes there, and you can set the default server game mode there as well. I'm not sure if that matters too much, but and then we want to just set the default to our test map. When the game loads up, it's at our test map, and then our game instance needs to be our SGame instance. So you can see now, like these settings, it's asking to restart, and if we go to our game data, sometimes you won't get the map coming up. You won't be able to select your map. So if that's the case, just do a restart and then come back and do this. But if it seems like it's working, then you can go ahead and start just filling this out with some defaults. So I'm going to do 2. I'll call this, just so we can recognize it, I'm going to call it default map name, and default description. Call that default name. I'm just going to set that to my logo. So this is the default one. We do want it to show menu, but we don't want it to include in the game list. And by game list, I mean when you're hosting a game, you can choose this as an option. If you choose this as an option, it'll be a menu. So you don't want to do that. And we don't have any classes yet here, so they can stay to none. So now we have a default. Doesn't do much because we don't have any UI class to do it, but yeah. So let's restart our editor. I'm going to actually just close and relaunch through Writer. And now, while we're out of the editor, we're going to do the next part, which is, this is the CommonGame part of the setup. So in the framework, we just want to create a new class, and it's going to be called primary-game-layout. And it's going to inherit off the primary game layout. And we want to put this under framework UI. So this is where we create our stacks. So we're going to initialize, and then protected, we'll put our widget binding. So this is going to be the primary game layout just inherits from CommonUser widget, and in turn inherits from user widget. So we're basically just looking at a widget here with some additional functionality. And what it is, it's a widget that overlays all widgets sort of thing. And then these stacks, think of these as like containers that you can use at different points. So the first one is what we set. If you recall, we set up all the gameplay tags. So we've got the game stack. Just going to duplicate that. And the next one is the game menu stack. So the menu in the game. And then got just the menu stack. And then we'll have a modal stack, which is like pop-ups and prompts and stuff. And because it's going to be a widget thing, we're just going to make it abstract. Now we need to set up the native initialize, because when we initialize, we need to register these stacks so we can access them. And that's where we're going to need to reference our UI layers again. So in the primary layer, in this primary game layout, there's a register layer. And it's going to ask for a tag and the layer container, which the layer container being like the containers, the stacks that we just created. So we're going to use our UI layer tags, which you can see at the top, it's included our static game data to reference that. And then we just need to create one for each stack. We need to register each stack. So that's the game stack. And I'm just going to copy these last ones in. You can see it's pretty straightforward. And that is it for that. We can close that off. So now we're ready to go back into the editor again and finish that part off. Back in the editor, we're just going to create in our framework folder, just going to create a new folder for UI. And we're going to create a new widget blueprint, which will be our S primary game layout we just created. And we'll just call it widget primary layout. I might as well call it primary game layout, eh? Keep the name. Doesn't really matter what you call it, to be honest. And then in here, we just need to assign our stacks. So I'm just going to put overlay, and then the stacks actually are still under uncategorized. So yep, beta. And then we just put the stacks in and we'll name them. So we can see the names here that we just assigned. So it's a game stack. And just need 4 more. This is going to be game menu stack. And this is going to be menu stack and modal stack. Written that enough times now, it should be locked into your brain. Oh, we just need to make sure these are full screen too. Stretch them full screen. And that is all we need to do in there. And now, if you're using 5.3.1, you're about to suffer an error. So we need to create a blueprint, and this will be our UI policy. And this is, the UI policy is what loads your primary layout and handles interfacing to it and all that. So the blueprint, isn't it? UI policy. If you're using 5.3.0, I think you should be right. But I've found with 5.3.1, I get an error here when I try to assign the primary layout. So if you're using a different version, you should be right to just assign that in here. If you're not, it's going to crash, and it's for some reason it's crashing on a lookup for the world, and it only does it the first time. But I'll show you how to get past it. So it's just going to crash here. There we go. It's hit a breakpoint, right? So it's doing a cast checked, and it's hitting that checked. I can show you how to fix that. What we're going to do is go into plugins, CommonGame, source, public. Actually, no, not public. Go private, and then you'll see your game UI policy here. And this is where it's failing, right? So it's returning null. I don't even know why it's doing this check when you're just assigning it for the first time. So we're just going to change this to cast, not cast check. And then where it's getting called from is here. So it's calling this function from here, and it's returning null. And then, so the reason why that's cast checked is because they're not checking null here. They want it to be valid before it continues this on. So what we're going to do is we're going to break this out. So we check that each one is valid before it goes on. And if it doesn't, we just want to return, and that just looks like that. So we're checking that the first one is valid. If not, we're going to return. If the game instance is null, we're going to return. If the world is null, we're going to return. Otherwise, we return the world. So I don't know why it's doing it. It's just changing it like this to return a proper null pointer without hitting the breakpoint just works fine. And you can actually change this back after you've assigned it the first time. You can reassign it, and you can do whatever. Something they've changed in the 0.1 update has changed it, so let's not get too worried about it. It's going to relaunch with those changes. And if you're concerned about changing CommonGame, like I said, you can just, once you've assigned it the first time, you can restore all that code back to how it was. If in the future, if you need to update CommonGame, assuming the bug's being fixed, it should be fine. So before we go on there, what we need to actually do now is tell the game what UI policy to use. So we actually need to override another class. So I'm going to come down to UI here, click Add, Unreal Class, and we're going to search for a class called Game UI Manager Subsystem. And we're just going to create our own one. This is sort of like just a boilerplate type thing that you have to do. Create that. So we're going to need a few functions in here. We're just going to need a constructor and initialize and deinitialize. And then what this function is actually doing is it's checking if you want to display the HUD, and then it's loading the root layer widget, so that primary game layout. It's what handles loading it. It's creating a tick to check for that. It's adding a function to add it, and it's just, yeah, this handler is just the it's like creating a custom tick, I guess. I'm just going to build those. This is straight out of Lyra. This is how they handled adding that primary layer. So I'm just sort of replicating this function. You can go in there and then instead of S Game UI, it'd be Lyra Game UI Manager Subsystem, and it'd be exactly the same. So they're creating, in the initialize, they're creating a tick basically, and then on the deinitialize, they're closing off that tick. And then in the tick, they're checking, do I want to show the HUD? That's which is calling this function here. They're checking for the UI policy, and they're getting the local player. So this is so they can check the local players showing the HUD or not. And now we're just going to create a bool whether we want to show the HUD or not. We're going to cast to the player controller. And this is so we can get the actual HUD from that player. Getting a HUD reference. And then we're assigning the should show UI to the should show HUD. It's going to need a include for the HUD class. So the HUD class has a should show UI function, and I'm guessing there's some sort of timing stuff, so it only shows the HUD when it should be showing the HUD and things like that. So that's why they're interfacing to that class to check that. Once that's assigned, then we can just go ahead and, whether that ends up being true or false, whatever, it doesn't matter. We can then look at displaying the primary game layout, and include the primary game layout.h at the top, and the common local player, and the UI policy, game UI policy.h. I'll show you the includes in a sec. So now using the bool that they set up here should show UI, they're setting the widget state, whether it should be visible or collapsed, comparing that to the current visibility. If it's not the same, then we want to set it to the desired visibility. I think, oh yeah, I've not returned, sorry, I've got to return a true here. Not sure why they put a bool on that, but anyway. For a reason. Probably something to do with core ticker needs a bool return or something. And that's it. So that's the includes at the top there. Make sure you got those. Everything should be hunky-dory. I found this a little bit messy, to be honest, but it works. It's what Lyra had, so I'm not going to change it. There's no real point tidying it up. So now we can load back up to the editor and sort out. Oh no, sorry. Before we do that, we need to actually define in our game UI the UI policy. So if any project that you bring this plugin that we're creating into, you'll need to add this to the game UI, unfortunately, but it's not exactly a massive bit of code. So whatever you've called your plugin, that's what you want to point to, and then we're pointing to that class that we just created, and then we're setting the default UI policy class. So for whatever reason, and probably the same reason why this CommonGame isn't available in plugins, this hasn't been made available in, like your project settings yet. You know how we changed the viewport client and the local player class, then this just hasn't been included yet. So that's why we're assigning it here. Normally this would just be set, I assume, through your project settings or something. And this path here needs to be the same as the path. So if you recall, we had content, framework UI, and then we had our blueprint for our UI policy. So just if you've done different directories, that's what that is. And if you go to the class that we just created and go to the parent class, you'll see that's the class there. So this is what we're assigning here. You can see it's got a config setting, so that's why it's in the config, the ini file. And we're just assigning this default UI policy class and telling it what to use. And if you don't assign this, then it creates its own, but we want it to use ours, obviously. So it points to our primary layout. So now we should be good to fire up again. Back in the editor, we can fire up our UI policy again and assign our primary game layout without crash. And that is probably the end of this episode. And the next episode, we're going to be looking at creating all our UI for our hosting, joining, displaying sessions, and all that fun stuff. Please don't forget to like if you found this tutorial helpful, and subscribe so you don't miss out on future tutorials. You can join me on Discord or sign up to my Patreon where you can get access to all my tutorials early and the project files, as well as gain access to behind the scenes on my current game development. If you have any questions, leave them in the comments. Thank you for watching. See you next time.